All right. So use substitution again. Use substitution. What is going to be my u? Okay, and how do we know that? How do we know that's the right choice for my u and not my 4x? Because what's the derivative of u now? One has to be the derivative of the other. If it's not that way, then you pick the wrong u. Okay? One has to be the derivative of the other. Okay? So, let's rewrite this, shall we? I have the integration of, I'll call this 1 over, u is going in here right now, so square root of u, and we still have 4x dx, so this comes out this side. Now, into my 4x dx, I can just put du. So, I now have the integration of 1 over, I'll call this u to the 1/2. It's easier to take derivatives and integration when we have exponents. And this now becomes du. I'll even take it a step further. What else am I going to do? I'm going to flip it, because it will be easier. So the integration of u to the negative 1/2 du. So, what do we got? Right, we got to add 1 and then divide by that number. So we add 1 to the exponent and divide by that. So we have u, the negative 1/2 plus 1, all over negative 1/2 plus 1. So that gives us u to the positive 1/2 over 1/2. And how can I simplify that even more? I can, but how can I make it so it's not a fraction? Okay. All right. If I multiply the bottom by 2, it cancels. I also got to multiply the top by 2. So I now have 2. Well, 1/2 is the square root, right? Square root of u. And what was my u? So x squared plus 1. So I have 2 times the square root of 2x squared plus 1. And there we go. All right. So, I'm going to change these right now. I'm going to say it's the integration of the sine of x to the 1/2. All right. Over x to the 1/2. Yes. So, I'm going to say, all right, my u, well, that's just x to the 1/2. What's the derivative of that? I bring my 1/2 up front, times x to the negative 1/2. Okay, well, what is, what's x to the negative 1/2? That's the same thing as saying 1/2 times 1 over x to the 1/2, isn't it? So the x to the 1/2 is in the bottom of the fraction. It is here. That's good. But, silly us. Dx. So So let's clean this up, what du is. Du is actually 1/2 x to the negative 1/2, which we wrote, right? Dx. We know that this, x to the negative 1/2, is the same thing as 1 over x to the 1/2, which is good, because I'm going to want this to substitute in, aren't I? For this and this. I'm going to write this out even more so it's obvious. I'm going to change that again. This currently is the integration of the sine of x to the 1/2 times 1 over x to the 1/2 dx, isn't it? We have that over there, but what do I do with the 1/2? I want to substitute in for just this. So I want just this. What do I do with the 1/2? Times both sides by 2. So now a 2 du is going to go in for my 1 over x to the 1/2 dx. Not just du, 2 du. All right? Does that make sense? Because what I'm substituting in for, I got to isolate. And I did, which means that 1/2 has to come over and become a 2 du. It's no different than this. This happened to match exactly. That's why it's 1 du. Okay? If this would have been times 3, well, in order to get this alone, wouldn't I have to divide that by 3? Yeah, I still got to substitute in for what I need. This. Everything else comes to this side. Okay? I need this. Everything else is come to this side. So now, it's the integration of the sine of u times, and this becomes 2 du. What happens to the 2? Yeah, it's constant. I can kick it out until I'm done with the whole integration. So my 2 is 2 times the integration of the sine of u du. What is the integration of the sine of u? Be careful. You sure it's not cosine? It is negative cosine. It's negative cosine. It is negative cosine. You do, and you just did. Because if I take the derivative of cosine, okay, the derivative is going to give me negative sine. But I want a derivative that will give me a positive sign, which means if I flip this, I have to flip that. Okay? So, we now have this integration is going to be 2 times negative cosine of u, which is negative 2 cos of u. And what was my u again? Radical x, x to the 1/2. So I will say negative 2 cosine of radical x.